Started with DevOps on AWS. My name is Yang Meng, and I'm a solutions architect here with AWS. It is amazing to see how DevOps has been gaining momentum over the years. Today, almost every organization, big or small, wants to be more productive and more agile. That's why they are looking to bridge the silo between dev and ops, hence what we call DevOps. Now, DevOps is not a product. It's a culture, a movement, or even a transformation for many companies. I'll be speaking for the next 15 minutes to give a broad view on how do we view DevOps and also introduce some services that help development teams deliver faster and more reliable updates to their end users. I will then conclude the session with a demo on how you can build a full CI/CD pipeline with AWS code services. So, a quick overview on what I'll be covering. I'll start off with explaining what DevOps means to us and how CI/CD fits in the picture. I will then introduce you to some of our AWS serverless capabilities that can help you to automate your DevOps pipeline. Finally, a demo which I will show you how to set this up yourself via the AWS console. So let's start by talking about DevOps. In Amazon, here's what we think, right? DevOps is made up of three key aspects: culture, practices, and tools. We believe that the combination of these help to increase an organization's ability to deliver applications and services at high velocity and at scale. Culture. Culture is made up of a few things that involves mainly the mindset. For leadership, what is the strategy, vision, the mission of the top management? Do they value what it means to be agile? In the organization, is there a learning culture in place? Does everyone understand what it means to develop modern applications? The individuals, are they stuck to the old traditional mindsets of software engineering? And practices, right? So these are mainly processes in the organization. Do you practice loosely coupled architectures? Do you do small but frequent deployments to reduce your risk of application defects? Do you enforce good coding practices? Does the organization follow microservices patterns? And so on and so forth. And then tools. Right now, having the right culture and practices is still not enough without the tools to ensure that the teams are productive. Organizations increasingly want to push out smaller, frequent deployments, but doing so manually is not sustainable. You need the tools to automate this process. In most modern application development, you will almost always see these 4 stages of release process. You start off at the source stage, where you have the code base of your application. These are your Java, Python, or C# files, depending on the programming language or framework that you use. At the build stage, that's where the application is compiled or packaged. You typically pull dependencies required by your application here and perform unit tests, for example, at this stage. At the test stage, you conduct additional testing on your application, such as integration tests with other systems, or perform load testing on your application to see how well it performs under high load. And at the deploy stage, you will deploy your application to a staging environment, perform some smoke tests on it before you finally deploy your application to production. Looking at this, without an effective DevOps practice or proper tools in place, many things could go wrong. In fact, many of you may already have experienced some of these issues. Right? At the source stage, without a proper code versioning tool, merging code changes across multiple team members would be a nightmare. Without proper code branching practices, development teams may also end up coupling each change so tightly that it is almost impossible to find and roll back changes when there is an issue. At the build stage, if developers are manually updating the configuration files, certain fields could be left out and end up breaking the application. Right? Teams using build servers may also face resource constraint when too many people are using the same set of build servers for all their builds. And then at the test stage, without automated testing, this usually falls in the responsibility of the QA testers. Right? They typically run through a checklist of test cases, and if development teams roll out changes very frequently, they could quickly get overwhelmed and therefore compromise on test accuracy. And then at the deploy stage, if done manually, requires the server to stop in order to update the existing code version. Now, this results in downtime and can impact users. Difference in environments such as dependencies versioning or environment variables very often result in situations where defects are found in production, even though it was working well in a staging or development environment. Also, when defects are found, rollback may be hard to apply without knowing which components of the application have been changed. And because human errors are inevitable, the goal of CI/CD is to automate the entire process. With the practice of continuous integration, the CI in CI/CD, these are some of the goals. Every time a developer checks in code into the code repository, it should automatically kick off a new build, followed by automated testing in a consistent and repeatable environment. If at any point in the build process a defect is found, the build should fail and developers be notified on the issue. With continuous deployment, CD in CI/CD, right? It goes further to deploy the artifact into your staging environments for testing. When test passes, it gets automatically deployed into production. This means that developers are continuously shipping new features and customers can provide feedback on them very quickly. On AWS, we provide the following tools that can be used for automation in your CI/CD pipeline, and I'll go over each one of them in detail. Let's start with the source stage on code commit. So AWS Code Commit is a fully managed code repository service which provides the same Git experience that you normally use, right? With the objects stored in S3, it inherits the scalability, availability, and durability of Amazon S3, which ensures that multiple copies are stored across several availability zones. One of the popular best practices when committing code is to use the GitFlow branching strategy, or some people call this trunk-based branching. Basically, with agile methodology in practice, each code change should correspond to a user story, and a feature branch should be created from the development branch to apply this change before merging it back. This helps you to keep track of each change in case you need to roll back certain features. The dev branch will eventually merge to a release branch or to the main branch, which represent the code that will be pushed into production. This helps to keep changes small and easier to understand. Now let's take a look at code build, which can be used in the build stage and also in conjunction with third-party testing tools for test stage. Code build is a service that can help to compile your code, run tests, and produce software packages. It is also a fully managed service, meaning that you don't have to provision any servers at all. This helps you to run your build process effectively at scale in the cloud. It processes each build immediately and run separate builds concurrently, which means that you will never need to wait for build capacity to be free. Looking at the CI workflow, code build has a hook that is able to detect any changes in the dev branch. This can automatically trigger builds as well as performing some of the third-party tests through shell commands executed in code build. Any test failure will then result in the build to fail, and error logs can be sent back to the developer to rectify them. Let's take a look at AWS Code Deploy. So Code Deploy is a service to help automate deployments in EC2 instances, in ECS, Lambda, and even on-premise servers. You can use Code Deploy to avoid downtime by taking care of the logic behind picking which instance to update, stopping new connections from coming to your old instance, and draining out existing traffic. Code Deploy can also be configured to watch for the health of the deployment and handle rolling back of the change quickly. Code Deploy can also help you to perform blue-green deployment as well as Canary deployment. Now, AWS Code Deploy allows you to choose a deployment technique that is suitable for your environment. The aim is to help you introduce changes slowly in production so as to reduce the blast radius in case there is any defect introduced. And if there are defects found, you can quickly roll back to the old version easily and quickly. There are two deployment strategies, blue-green deployment and Canary deployment. Let's have a look at how blue-green deployment works. Let's say you have an application version 1 running on your EC2 instances and are serving live traffic to users. You push out a new release. Let's call it application version 2. This is called blue-green deployment typically because we refer to the old version as blue version and the new version as the green version. Now the green version gets deployed and you can perform tests and validation on them. Note that at this point, live traffic is still not routed to the green version 2, and any defects found from the test would just mean that this version go back to be fixed. And if all tests passes, the load balancer can switch traffic to the green version without any downtime for the users. Note that at this point, if defects are still found, you can easily swing the live traffic back to the old blue version as it is still running. After a specific amount of time without any defects found, you can safely terminate the blue application infrastructure to save costs. The advantage of this is that you can provide zero downtime deployment by leveraging on the benefit of the cloud, the ability to easily spin up instances and tear them down quickly. The disadvantage, though, is that there will be some added cost and time for creating the new environment. Let's now take a look at Canary deployment. Now, the reason why this is named Canary deployment came from the 1980s. Right? Canaries were used by coal miners as an early detection system. In the mine itself, there could be harmful toxic gases which are not visible and are odorless. Because these canary birds have a higher metabolism rate with rapid breeding, they would die very quickly if there are presence of toxic gases. The miners would then be alerted and evacuate the area. Similarly, Canary deployment are also a form of early detection system. As compared to blue-green approach, it takes a more risk-averse strategy via a phased approach of deployment. It works by shifting traffic slowly to the new application version over time. If at any point a defect is found, the traffic will be routed back to the old version as a quick rollback. If no issues are found, traffic can continue to shift over to the new application version until all the traffic is being shifted. You can then terminate the blue version if all tests are passing and you have no need to roll back. The advantage and disadvantage of Canary deployment are similar to the blue-green deployment. From a CD, continuous deployment perspective, code deploy helps to take the build artifact and automatically deploy it to the target environments in test, staging, or production environment. With the ability to configure blue-green deployment or Canary deployment out of the box, it saves you a lot of time to manually write scripts to automate the deployment of your application safely and effectively. The reason why the AWS code services have different tools for different stages is because they are purpose-built and are fully customizable, just like Lego blocks. So you can use each of these services individually. For example, you can swap out code commit with GitHub or simply use the whole suite to build your pipeline. Finally, Code Pipeline helps you to chain up the whole process from end to end. AWS Code Pipeline is also a fully managed service, which means you don't need to run or manage any servers as well. The key benefit of using Code Pipeline is that it has a very wide integration with not just AWS services, but also other third-party tools. So you can trigger things like a third-party load test or even integrate it with Jenkins. With Code Pipeline, you can visualize how the pipeline looks like and set up automation that specifies which stage comes first. You can perform builds or execute tests in parallel, or add approval stages and notifications into your pipeline. You can also create pipelines that span across multiple environments, across multiple accounts as shown. And now for the fun part. Let's look at the demo. Let's assume that I already have my Java application code committed in my AWS code commit code repository. We will see how we can use AWS Code Build to build it. From the AWS Management Console, search for Code Build to access the service. First, create a build project. You can give it any name as well as a description. So in my case, I'll be giving it my code build project and a short description of this. Select source provider as code commit and select your code repository. Select the branch, and I only have one, which is the master branch. Select the image that will be used for your build environment. I'll use a managed Ubuntu image. Select the service role. I have already pre-created a code build role that will grant code build access to S3 to drop the output artifact. Select the option to use a build spec file. Now, this build spec file will specify the exact steps required to build the Java application. As you can see here, there are different phases in the build spec file. And what's really important is the Maven install command. Next, Select S3 as the destination for the artifact. I will give you a name called web app output artifact.zip. Select CloudWatch logs if you want to be able to collect the build logs. Finally, create your build project. Now let's start the build for our application. Click on Start Build. Ensure that the build project is selected. Source from code commit and branch is master. Let's start the build. You will be able to monitor the logs from the console itself. Once the build is complete, let's take a look at where the artifact was uploaded. And as you can see here, the file is in S3. Now, let's see how we can deploy the application. In my VPC, I already have two EC2 instances as my development server. I'll be showing you how you can use code deploy from the console to deploy the application into it. First, go to code deploy. And on the left, go to applications and create an application. Give it a name. And since I'm deploying into EC2 instances, I will select that option. Once done, let's create a deployment group. Now, deployment groups are essentially targets of your deployment, and you will usually create one for each of your environment. Give it a name. I'll name this web app dev for my development environment. Select a service role. Again, I've already pre-created a code deploy role that allows code deploy to access S3 to retrieve my build artifact and to deploy them onto my EC2 instances. We will do in-place deployment for this. Select EC2 instances. I'll be using tags to help code deploy identify which instances which it should deploy to. And as you can see, I've already tagged my EC2 instances with the value dev web app. And in my EC2 instances, they have the same tags. For deployment settings, I will leave it at all at once. I will also select the load balancer so that it will first block traffic to the instance before deploying. Finally, create the deployment group. Now let's create a deployment. Enter the location of the build artifact in S3. You can leave the remaining of the fields as default. And create deployment. Code deploy will run through a sequence of lifecycle events for the deployment. As you can see here, these are the list of the lifecycle events. Skipping ahead, once done, we can head over to see our EC2 instances. Opening the page, yep. So we have the IP address, and now let's try and open it in our web page. And here, you can see the application being deployed in your development environment. So now let's take a look at our production environment. In my VPC, I already have another two EC2 instances as my production server with an application load balancer, and the instances are in auto-scaling group. Right, let's go back to our code deploy application, create another deployment group for our production. Enter a name. We can call it web app prod. Select a service role. This time, we'll do a blue-green deployment. I can select the option to copy my current auto-scaling group to launch the green instances to deploy the new version of my application. Select the auto-scaling group. You can also choose the deployment settings, whether you want to reroute traffic immediately once deployment completes, or choose a duration before it swings over the traffic. You can also specify how long you want the blue instances to remain before terminating them. Right. Now choose the load balancer for the production instance, and let's create the deployment. So if you look at the architecture diagram, once I start deployment, code deploy will create new EC2 instances in another auto-scaling group. And let's start the deployment. Enter the path of the artifact. I will use the same build artifact that is in S3. I will select to also overwrite any existing version, and finally create the deployment. So code deploy will then first create 2 additional EC2 instances, as you can see here. So you see the 2 new instances are being initialized. Once done, it will try to deploy the application code on it. And the third step will be to reroute the traffic. So once the traffic has been rerouted, it will then wait for 1 hour, which is actually the duration which I had specified earlier. But before it terminates the blue instances, I can also manually tell code deploy to terminate them. And yeah, they would be terminated. So now let's see if our production is being deployed correctly. I can take the IP address and open up in my web browser. Now, in a normal CI/CD pipeline, you probably won't want to go in to manually click to build, or even to click to deploy the whole thing, right? So let's now take a look at how we can use AWS code pipeline to automate this whole process. So in the AWS service dropdown, click and select code pipeline. And you'll see the AWS code pipeline console. Click on create pipeline. Enter a name for the pipeline. You can then let code pipeline create a service role for you. Select a custom location to store your artifacts. I'll be using S3 bucket that I've created earlier. And next. For source, I will select code commit. Select your repository name. And the branch that I'm watching is master branch. And select code pipeline to let it watch this branch for any new commits. As for build, choose code build. Select the build project that we have created earlier. You can also add additional environment variables if you have, right? Things like connection strings, environment variables can be added. And then for code deploy, I will select code deploy, select my application and the development deployment group, review the changes. After you go next. And finally, create the pipeline. Once it has been created, you'll see that the pipeline would be started. But we're going to jump ahead. We're going to edit this to add a few more things to our pipeline. So after you click on Edit Pipeline, you add a new stage. We're going to create a manual approval process here before we deploy into production. So action provider will be manual approval. Select the SNS topic, which I've already pre-created. So this SNS topic will have a subscription that will send an email to the approving authority to approve this once it reaches this stage. Next, we will add another stage here, which will deploy our production application. type in an action name for this. And for this action, select code deploy with the input artifact from the build stage, from the build artifact. Select the application name and our app production deployment group, and save the pipeline. Now we will head over to our application code and make some changes to it. So I'm using Cloud9 as my IDE over here. And going to my Java code, I will then try to make a change in one of the lines at the title. Let's change this to a test message. And remember to save the file. OK. And let's commit this change into Git. Give it a commit message. And finally, push the change in. Now, once the push goes through, it will trigger the code pipeline to start building the application. And once the build completes, it will deploy to development. So you can monitor to see how the deployment progresses. Right? So you can see here, I've made the change to the title as the code commit message. And let's look at the code deploy in detail. So it's going to do in-place deployment as well for the 2 instances. And once it completes, it will send out an approval notification email. So let's now take a look to see if the change that I made to my application has been reflected in the website. Right, so there you go. You can see that the test message is here. And the approver can go in and enter some approval commands and approve this before the stage moves to the next. Once approved, it will kickstart the deployment into production. Right, so it will make use of the blue-green deployment as we have set it up earlier. You can monitor how it goes. And you can see here that it will launch 2 additional instances again as the green environment. Let's skip ahead. It goes through the whole blue-green deployment, and it terminates the blue environment. Let's now test if our production has been deployed successfully. Let's take the IP address, put it into our browser, take a look, and there. So the test message is now pushed into my production environment. So you can also test if the load balancer is correctly forwarding the traffic to your production instances as well. So I'm going to head over to my load balancer and get the DNS address, copy it, and put it in my web browser. And there, all good. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. Attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think.